All right. Welcome to Forward Future Live today, August 22nd, 2025. And we do have another amazing show for you today. We're going to be talking about Deepseek, Grock, Meta Superintelligence, a bunch of other news stories from this week. We also have three incredible guests. First, we have Greg Cameron, from president of the ARC Prize, the nonprofit responsible for ARC-AGI benchmarks. He'll be talking to us about ARC-AGI 3, their third iteration of their AI benchmark, as well as generally just progress towards AGI. Then we have Charles Packer, the founder of Letta, an AI agent memory startup. And of course, we'll be talking about all things AI agents and memory and why memory is important, how much of a moat is it, and what they're doing that is unique. And then last, we have Alan Liu, director of multimodal at Skywork AI, the company responsible for Matrix Game, which is the open source, fully controllable world simulator. And so think Genie 3 from Google, but open source. And it is really cool. And as usual, we also have Alex producing the show, making sure everything goes as smoothly as possible. So welcome, everybody. But first, I want to bring on the guest co-host for today's show. This is my business partner on all things Forward Future, including our newsletter, forwardfuture.ai. And this is Nick Wentz. Please join me, Nick.
Hello, everyone. Excited to be here. We have quite a good lineup for guests. We got some great stories we're going to cover. Let's get into it.
All right. So welcome, everybody, streaming us from all over the world. I see India, I see Mexico, I see Miami, everyone all over. Welcome. We have a fun show for you today. Let's get into a few stories before we bring on our first guest, Greg. So Nick, Deepseek V3.1 was announced this week. Alex, if you can share my screen, that'd be great.
The whale is back.
Yes, indeed. So we have a new iteration of the Deepseek V3 model. This is not the R series of models. This is the V3, I guess it's called. And this is a hybrid model. So this seems to be the trend of frontier models lately. And by hybrid, it means both thinking and non-thinking. So you get the low latency of the non-thinking version. Plus, if you need that extra oomph to get the really hard problem solved for you, it'll take that extra time and actually think through it.
Yeah. I think there's kind of three interesting things here. One is hybrid inference for sure. Definitely seems to be the trend to your point. And then we have better agent skills. I think this is another trend that we're seeing from frontier labs. DeepSeek wants to get in that race. Understandable.
Yeah. This is exactly what GPT-5 is, right? It's the hybrid model. It's the ability to have both fast, low latency, low cost, and then slower, harder problems. Take your time, get the answer right if you really need to spend that extra token budget.
That's right. So are you more of a fast mode guy or deliberate mode guy?
So I think I'm actually in the minority on this. I 99% of the time prefer speed. I want to get the answer fast. And so if I have a very capable model connected to the internet, that's all I need for the vast majority of my use cases. There are few and far between times where I actually need that extra thinking processing power. So GPT-5 Pro, I use it, but only occasionally. And yeah, the vast majority of my use cases, I just don't need it. What about you?
I'm a fast guy as well. I'm seeing in chat that we have a few thinking mode fans. If you are a thinking mode fan, let us know what use cases you're using it for. I'm mostly fast as well. Let's talk about pricing though, because I think this is where it gets pretty interesting, actually.
Yeah, let me pull that up. All right. So Didi from, I believe, Menlo Ventures. Yeah, VCM Menlo Ventures. China's DeepSeek is at it again with the best open source model drop, V3.1, scoring 66% on Sui Bench and costing a $0.50, 56 cents per million input tokens. That is 2 times cheaper than GPT-5, which, by the way, is quite cheap already, especially compared to the Claude family of models. $1.68 per million output tokens. That is 6 times cheaper. And so, yeah, he says the whale is back, and you can see the different benchmarks: Swede bench verified, multilingual, and terminal bench, and just absolutely dead cheap pricing. And that,
Six
look at the cash hit too, by the way.
6 times cheaper is insane. I mean, if those numbers hold up in practice, it makes DeepSeek extremely attractive, especially for your coding data analysis use cases. I mean, that's insane. And
Yeah.
so the Sui bench, 66%. I'm forgetting what GPT-5 is. I know it's higher, but it's close,
Yeah.
right? It's competitive.
Yeah, no, it's comparable. But look, if you need cutting edge coding models, you're probably going to go for a Claude or a GPT-5. But I still think this is really powerful. And for like the vast majority of use cases, the latency, the cost, this is extremely attractive as a model for a lot of people. Plus, of course, I believe it's open weights, so you can download it, you can run it on your own hardware. It seems like a very good value prop to me.
Definitely. Pretty
All
impressive.
right. Next story. We're speed running through these, and then we'll get to our first guest. Hundreds of thousands of Grock chats exposed in Google results. I guess not too surprised about this story. Obviously, the Grock team's moving very fast. When you move fast, sometimes mistakes are made, and I think, by the way, they're not the only ones, right? I think OpenAI had some of this when I believe it was like automatically opting in people to sharing their chat history, and then that automatically got it indexed in Google, and it seems like Grok has the same issue.
Yeah, it's definitely not exclusively a Grok problem. To your point, OpenAI, I think Meta also had some leaks earlier this year. So the pattern seems to be AI companies kind of pushing this sharing discovery feature. And it's obvious why, right? Like it's great for exposure. There's kind of a viral component to it, all that stuff. But then, they're going to walk it back once the privacy blowback happens. So I assume Grok will do the same. They'll patch this pretty quickly.
Yeah, there's a ton of value in sharing conversations, sharing prompts, and so I understand it. Obviously, you want to be very proactive with telling the user, "Hey, this is going to be shared. Are you sure you want to share this? This is going to be indexed." And so this is certainly a mistake. They need to patch it up, and I think they probably already did.
Yeah, and to be like clear, this is alarming, right? Like I share a lot of sensitive information in my chats. I don't know about you, but I'm giving away details. I find the more that the more transparent you are with the model, like the better output you get, right? So
Yeah.
this definitely needs to be fixed.
Yep. All right, let's go on to our last story before we bring on Greg. Big changes at MSI, Meta Super
Again.
Intelligence.
Yeah. I mean, again, this is like the fourth major reorg in 6 months or something.
Yep. So Alexander Wang, acquired through the Scale AI acquisition, now running the Meta Superintelligence Labs. Looks like he's running everything. Here's the key bit that kind of stunned a lot of people, or maybe didn't. Jan LeCun will report to Wang. Jan LeCun is or was the kind of leader at Meta's AI labs, the FAIR group, FAIR. And now all the groups, I believe, are reporting into Alexander Wang. And so, yeah, in a memo, Alexander Wang wrote that superintelligence is coming, take it seriously. And the MSL, not MSI, research will be led by Shengjia Zhao. Hopefully I'm pronouncing that correctly. Meta is centralizing research across 2 units, TBD Lab, that's to be determined, unnamed yet, a small team focused on training large AI models, and FAIR, Meta's long-standing AI research organization. Now, the interesting thing is, it seems like some of the organization is going after the transformer architecture, the large language model architecture, while at the same time, Jan LeCun has been extremely vocal in saying that he doesn't believe AGI/ASI is going to be reached with large language models. So definitely some friction internally, I assume.
Yeah, I'd agree. There's probably some tension. I mean, you have new leadership. You certainly have some pay discrepancies. So it's going to be interesting to see how this plays out. By the way, do we have that tweet for LeCun's presentation that he did? There's a pretty good quote there.
Yeah,
It's
I
something
don't have it
around,
in front of me.
Yeah, if you are interested in human level AI, I think it is, don't work on LLMs. So yeah, it's
Yeah.
interesting dynamic happening there.
All right. So let's get to our first guest because we want to hear everything he has to say about ARC Prize, AGI, everything. So please welcome Greg Cameron. Greg,
Hello, crew. Matt, thank you for having me.
what's up? Good to see you again.
Good to see you again.
All right. So for those of you not familiar with what Greg does and what the ARC Prize is, Greg, can you just give a very brief breakdown of what the ARC Prize is and what you're doing there?
Yeah, absolutely. So my name is Greg Cameron, president of ARC Prize Foundation. Now, we are a nonprofit, and our goal is to bring forward open AGI. And when I say open, that's very clear here because we believe that the answer to AGI, as it is a piece of technology, should be out there in the open. That's the way you're going to solve safety. That's the way you're going to solve alignment if it's decentralized with everybody there. So we're a nonprofit, and we use benchmarks as a tool to elicit research out into the open. So we host an open source competition. We host open source paper prizes for the best research. And specifically, what we're most well known for is the ARC AGI benchmarks. Now, we have a very opinionated view about what intelligence is, and we believe that the ARC AGI benchmarks go and measure that opinionated view of intelligence. We had ARC AGI 1, which was introduced by Francois Chalet in 2019. We came out with ARC AGI 2 just in March of this year in 2025. And then what's in the works right now is ARGI 3. But let me pause there. We can go any direction you want there.
Yeah. So talk a little bit about what these benchmarks are, because it is very different from any other benchmarks that I've seen out there,
Yeah.
and why you took this opinionated view and how these specific benchmarks measure against that very opinionated view.
Yeah, absolutely. So it all starts with Francois Chalet's 2019 paper on the measure of intelligence. And in that paper, he actually makes a proposal for a definition of intelligence, which it's kind of weird even needing to say that in the first place, because out there in the industry, you would think with all the hype around AI, we'd have a formalized definition of intelligence, but that's actually not the case. Not only that, you'd think we have a formalized definition of what is AGI. Like even in the OpenAI Microsoft scenario, they're attaching AGI to revenue numbers for,
Right.
it just, anyway, that's a whole separate topic here. But in Francois's paper, he proposed that intelligence is defined as your ability to learn new things. Now, that may sound simple, but let me demonstrate it just a little bit more. We already know that AI can beat chess, any human at chess. We know it can beat any human at Go. We know that AI is getting even better at self-driving cars more than humans. Now, it's not officially all the way there, but it's getting very close. So given the right data, AI can learn anything it wants. However, that doesn't prove your ability to generalize to new domains, much like humans do. So what we use as our only proof point of general intelligence, which is the human, with the human brain, right? We have general intelligence in our head. And so using that as our existence proof, we can see that humans can learn new things. And therefore we define intelligence as your ability to learn new things. So given that definition, there's a question. Well, how do you actually test for your ability to learn new things? It's kind of an interesting question. And this is where Francois came up with this benchmark, ARGI. And it's a little bit like think of it as almost like a meta benchmark, because each question is decomposed into two parts. We're going to teach you something, and then we're going to ask you to demonstrate that you've actually learned that thing that we just taught you. So ARGI 1, we teach you a small little transformation that's just a couple of pixels and you're moving them around and you have to understand how it works. And then we ask you to demonstrate it from there. So that's ARGI 1 and ARGI 2. And then the interesting part is ARGI 3, where we're going with this, is actually via interactive video games. So we're actually going to drop the test taker into an unknown environment, and they have to learn how the environment works, what are the rules, and see if they can successfully complete that environment, demonstrating that they've actually learned something.
Yeah, and not only that, I think the kind of theme throughout the different benchmarks is it should be easy for humans, but difficult for AI. Is that right?
Yeah, so that's actually one of the parts that makes us unique as well. We love problems that humans can do and AI cannot do, because our hypothesis is as long as you can find those class of problems or those types of problems, that tells you a couple things. Number one is it shines a light on what's missing from current AI between that and a proper AGI. Because if you can show something that your existence proof of general intelligence can do, which is humans, but current AI cannot, then clearly there's a gap. But then this also leads into our definition of AGI. And this is more of an observational definition. And it is, as long as we can come up with problems that humans can do, but AI cannot, then we do not have AGI. And the inverse of that is also true, which is when we can no longer come up with problems that humans can do, but AI cannot, then we do have AGI. And by virtue of having these benchmarks out there right now, and they don't have 100% scored on them by every single AI out there, that tells us that we do not yet have AGI.
Okay, so we pulled up one of the examples from this is a ARC-AGI 2. Maybe
Yeah.
just kind of briefly walk us through what is going on here. So if somebody's coming here, a human, how would they solve this?
Yeah, absolutely. I actually have a really good slide for this. Do you mind if I take over presenter and I'll
Yeah,
show you?
please share your screen. Alex will throw it up on stream.
Nice. Let me go ahead. Yeah, let me share a screen here.
Yeah, and so I got a preview of the ARC-AGI 3, so I'm excited for you to show that off a little bit too.
Beautiful. Let me make this just a little bit smaller aspect ratio. Okay, great. So like I said beforehand, each ARC-AGI 1 and 2 task is split into 2 parts. And our goal is we want to see, can you learn something new? Well, if we're going to test you on that, we have to teach you something and then see if you can do it. So this is one task that we have here. And on the left, this is the learn the skill side. So us as humans or the AI, the test taker, you look at this and you say, what is happening in this image between the input and the output? And your goal is to identify the transformation that's happening. So you can see here that we have a blue line extending out, and then here we have a green line extending out. So you have to understand the color, you have to understand the orientation. And just to clear up any misconceptions here, humans, we like to look at this as visual pictures. We give the data to the AI in terms of JSON. It can turn it into an image if it wants to. It can turn it into a video. It can read it raw JSON. We're agnostic as to the data format that the AI chooses to do it on, so whatever they want. Now, part 2 of this is like, okay, we just taught you a mini skill. Now go and demonstrate that mini skill for us. This is the apply the skill section. Then what you need to do is you need to fill out the output as a human to actually go and demonstrate that you've learned this thing. So this is me doing this output right here. And then if you get it right, you get a nice little confetti here. Now, one more thing that I'll say here is actually the really important part is we're only going to ask you to extend the line out of the top of the pyramid once, because we don't want to teach you that mini skill and then just ask you again and again and again, because if you've learned it once, by doing it multiple times, you're not demonstrating you've learned new things. You're just demonstrating that you can repeat the same thing that you've learned over and over. So for every single one of our questions, there is a different transformation needed. So you're going to learn a mini new skill and you're going to demonstrate that. And then ARC-AGI 2, our second version of our benchmark, there's over 1,300 tasks in there. So those are 1,300 little mini skills that we're going to ask you to learn and then go demonstrate that you've done us for us. And to your point, like I said earlier, or you said earlier, Matt, a human has done every single one of these. In fact, multiple people have solved these by themselves. And AI, I think the top score in ARC-AGI 2 is only 16% right now, which was done by Grock.
16. That's 1.6 on ARC-AGI 2, not
Yes,
even 3.
correct. I think the average person, when we went and did our testing on these, we actually went down to San Diego. We recruited 400 people to test on these things, because if we're going to claim that they're easy for humans, we need the first party data on them. And I think the average human solved 70% of the tasks they were given. And then if you had a panel of, I think 4, maybe between 5 and 10, I forget the exact number. If you had that panel, then 100% of the tasks were solved by them. So humans can do these, but AI is still having a hard time with them.
Yeah, this is incredible. And what do you think is missing from modern frontier models that they're not able to get higher than 16%? Is it just a reflection of the architecture of the models, their kind of failure to learn new skills that are not inherent in the data that they're trained on? What do you think that is?
Yeah, well, I tell you what, here, the number one thing that we're missing right now, and it's a hot topic right now, is the continuous learning or the adaptation at test time. And so you look at large language models, they're static models. And yes, you might be able to fit some new things inside the context window to try to make it learn some new things. But if you have out of domain data that's not inside the training data, it's going to have a really, really hard time with that. That's one of the things that humans are absolutely fabulous at, is sample efficient generalization. And what that comes down to is a human's ability to build a world model inside their head and effectively make prediction in a sample efficient way. So I don't know the exact answer. If I did, I'd probably be at an AGI research lab getting offers from Zuck. But what we do know is that we do know some of the key pieces that are missing from this.
Yeah, and I guess this is kind of proof that these models can generalize, but only a little bit outside of their training set, not really broad generalization. It just seems obvious. So then why you have ARC-AGI 2,
Yep.
which is far from being solved or saturated.
Yeah.
Why did you decide to make ARC-AGI 3? And by the way, what is different about it than ARC-AGI 2?
Sure, absolutely. So the reason why we decided to pull the work on ARGI 3 is uh, one is the simple answer is just stay ahead of where the world is going. I mean, it's as simple as that. These benchmarks take quite a bit of time to make. So we were expecting the timeline wise, ARGI 3 is probably going to take a year to make, of which we're already well into that. So we're expecting to launch in 2026, but we needed to start building it a while ago for that. We're not committing to a launch date of ARGI 3 because, we also got to see how 2 goes and just, go from there. So it takes a lot of time, takes a lot of money, and making benchmarks and maintaining benchmarks isn't easy. So we had to get a head start on that. Now, the other reason why we pulled ARC-AGI 3 is because the class of problems that we can find in which humans can do and AI cannot is getting smaller and smaller and smaller. Now, it's almost, the way I like to phrase it is, it's almost a privilege because AI is getting so good that it's getting harder for us to come up with these types of problems. But the next class of problems that we're going after is what we call interactive reasoning benchmarks. Now, the interactive part is you're going to have a back and forth exchange with this type of benchmark or with this environment. Now, that's in contrast to static benchmarks. Static benchmarks is just a question and an answer, but there's a new class of benchmarks that are coming around here. So we'll talk if the folks know terminal bench. Very interesting example in which you have an environment that's a terminal and you go back and forth. There's also Tau Bench out of Sierra, which is a kind of a customer service chatbot type of interactive environment. Now, ARC-AGI 3 is also an interactive environment, but it's going to be with abstract and reasoning environments here. So the way that it works is we're going to drop the test taker into an environment, and that's just a fancy way of saying basically a video game. And then without any instructions, the human needs to start clicking around and moving the different buttons, understand what are the goals, understand what you're supposed to do, and learn about basically how to exit the game and then go and successfully do that.
Yeah, and Greg, Nick and I both went to your launch event in San Francisco for ARC-AGI 3. By the way, thank you for that invite. I think like you guys were so strict on not giving the language model any information about the environment that you're about to drop them into. In fact, I think it was like a day before you launched, you guys made the decision to even remove the names of the games because that might just give a hint of what the game might be about, right? So like, why be so strict?
Yes, absolutely. So just very briefly on the game. Well, actually, no, let me go to the more foundational reason. So we want to test I guess let me even back up further from there. Simply humans can do it. So humans can figure out and explore in a sample efficient way a new environment, and that is well within scope of what our general intelligence can do for it. So if we're going to hold humans to that same standard, which is a high bar, we also need to hold AI to that same exact standard there, because again, we love the class of problems that humans can do and AI cannot. Now, the reason why we scrubbed the names, we used to give all the games really interesting names. That gave a little bit of a hint about how to go play it, but they're all in English. And what if somebody doesn't know English? Well, they're clearly intelligent. They're still clearly generally intelligent. They just don't know English. And we like the types of problems where no amount of preparation or pre-training will help you succeed on there. No specific pre-training on that. So for say, like that example, say someone is from Japan and they don't know English. Well, that wouldn't be a fair test to measure their general intelligence because we just happen to test on English.
And then can you show off a game?
Yeah.
Can you show what
Absolutely.
it looks like and how to do it? And I got to be honest, Greg, while you're pulling that up,
Yeah.
it's supposed to be easy for humans, but I tried it and
Sure.
it's not. I think I finally figured out the first one, but the second game was very difficult.
Sure. Yeah.
Greg, why don't we look at I think it was LS20.
Yes.
So this is the one I experimented with. I got to say, kind of breezed through the first level, got pretty stuck on the second level.
Sure. So let's go through this one.
Not afraid to admit it.
Yeah, this one's called LS20. And when you look at a static screenshot like this, you're wondering what the heck is going on, right? And down here at the bottom, it tells you which actions are available. And yes, we tell AI which actions are available as well. So you have up, down, left, right. And then you start to see, oh, I have a little agent that I'm taking care of here. Let me go over this dark thing. Nothing happens. Let me go over this light one here. Oh, the bottom left thing changed, and now it matches the same symbol up at the top one. So let me go up from here. cool. I exited the level. It's almost as if I found a key that made me, I was able to go do that. So let me go over
And
here.
those purple dots at the top, those are a limited number of moves, and the agent does not know that, right?
Nor does the human when they first drop into this in
Right.
the first place. And so I'm guessing that either you intuited that, or you could tell it's like, oh, there's something that's descending from here. Now that the key is matched up, let me try to go to the exit. Oh yes, I ran out of energy. Now I need now that you've learned that, you think to yourself, oh, I need to go get more energy up here, and then I need to go back down. Right. And so there's little environment tricks. We call these different game mechanics that folks need to go into. So now if you look at the key up at the top, you see that it's orange, but the bottom one is still white. Well, now we introduce a new transformation, which is I'm going to switch the color, but I'm being mindful of my energy. I need to go pick up more. And I'll just do this last level for here. I need to,
Yeah, you got further than I did, just to be clear.
yeah. Well, so let me just beat this one and then I'll pause from here. Like I said, for ARGI 2, we actually tested 400 people to make sure that anything that we included was doable by humans. And so we're going to hold ourselves to the same standard for ARGI 3. So if the testers from the general public, and keep in mind, these are just, there's a little bit of a qualification to come and test with us. You need to know how to use a computer and you need to know how to use the internet. But if multiple people can beat these games on the first run with no instructions, then it'll get included. But if they aren't able to do it, Matt, like you're talking about here, then we're just going to cut the game or cut the levels.
And then one last question about the games themselves. When an agent is dropped in, is it given any instructions? Are you telling it, hey, you need to solve the thing and then nothing else? Or are you literally dropping it in and say nothing?
So we will refine the base instructions that it will give, but more or less, we're going to tell it, not TBD, so don't quote me on it, but you're in an environment, your goal is to exit, and here are the actions that are available.
Yeah.
That's it. And but we have a kind of a motto internally. It's like, whatever you tell humans, or you got to tell AI, and whatever you tell AI, you got to tell humans too. So we're really trying to keep as much of a level playing field as we can.
Okay.
Hey,
So go ahead, Nick.
Actually, I'm wondering, Alex, can you pull up my screen real quick? Would love to talk about this action efficiency tweet.
Oh, I love that you did that. Yes, it's one of my favorite topics.
Yeah, can you walk us through this?
Yeah, it looks like we're looking at a different one here.
Yeah, I'm not sure this is the right screen here. Make sure you click share this tab.
Let's try that again here. There we go.
Beautiful. Yes, I love it. So one of the really cool parts that you get from an interactive benchmark is a new axes to judge the test taker on. So with static benchmarks, you're basically just looking at, did they give the right answer or did they not, right? Now, because intelligence is an efficiency ratio, basically, and the intelligence ratio would be in the numerator is what is your output of performance of your intelligence, and then the denominator is how much energy and training data did it actually take. And so this kind of puts brute force solutions into perspective here. One of the really cool parts about interactive benchmarks is now you can measure how many moves did it take you to complete the goal or to complete the game. And so if you've seen the Claude Plays Pokemon or Gemini Plays Pokemon graphics out there, they'll have the time or number of actions on the x-axis, and then they'll have the level progression on the y-axis. And you can kind of see the line go up, and see how it goes from there. And so we're going to do the same exact thing for ARGI 3. And we're going to do this for every single game that we have. And so we're talking about hundreds of games here. And what you're looking at is a graph of just one of these games. So on the x-axis, you have the total number of actions that somebody took. And on the y-axis, you have the level that they were able to progress to from there. Now, the red line, that is what the average human is going to look like. And so let me see here. It looks like at level 5, it took them a total of maybe 40 actions to get to level 5. Okay. And then level 6, well, level 6 was kind of long, right? And so now they're up at 90 actions for level 6. So what's cool is that these actions, they comprise of two things that humans need to do. They need to spend actions to explore the environment, so learn what the rules are. And then they also need to spend actions to execute in the environment, so go and actually complete the goal. What is so cool about this is we can plot the number of actions that it took AI to do in order to complete the same goal. So now we're not asking AI, hey, just do this task. We're asking it to do this task efficiently. And the benchmark or the baseline that we're asking AI to compete with is the human level baseline. And that's uber important because, again, we're using our only proof point of general intelligence as our baseline for what sample efficient intelligence looks like. And so when we report our scores, the score for AI will be baseline as to the average human level performance that we do, and we'll get that from testing, which we haven't done yet.
Super
And so,
cool. Just real quick
no,
question
yeah,
on
go
this.
for it.
So, as you are optimizing for efficiency, like what are the risks in that? Like, I can imagine that maybe you are penalizing the model for creativity or novel solutions. Have you thought through that at all?
Um, I think that we're not optimizing necessarily for novel solutions or creativity per se. I think that those two are very important, but that's not the focus of what we're doing here. Our focus is measuring efficient intelligence, and in kind of like a narrow scope and narrow domain for that. And I tell folks this all the time is like, look, if you're going to measure a holistic person or a holistic AI, you need a portfolio of benchmarks. There's not one size fits all for everything. So we're not claiming by any means that this is the best benchmark to measure everything you possibly would about what an AI can do, but we are claiming that this is the best attempt at measuring an AI's ability to generalize.
Very cool. Makes sense.
Okay. So you had an agent competition.
Yeah.
Tell us about that. And you have some results. So share those results with us if you can.
Yes, absolutely. So actually, I'm going to share my screen once more for this, and thank you for allowing me to jump around here. So we hosted an agent competition. I just shared it, and it was just 30 days long, so it wasn't too long. But we wanted to really battle test these different games, right? And we had a whole bunch of really awesome submissions. And this is what the leaderboard actually looks like on the other end. Let me zoom out just a little bit here. And so a fellow out of Tufa Labs out in Switzerland, he submitted a Stochastic Goose. And what was really cool is this is basically a brute force agent, but it is an intelligent brute force agent. So it tries a bunch of different actions, and then it sees what actions actually result in the screen actually moving. And then it says, oh, maybe I should just go try those. And then it basically exploits those actions that actually did something. So it won, it got 12%. The scoring mechanism that we're going to use is still in flux. And so I won't read too much into this, but it was able to complete 18 levels on the private test set. And it did those 18 levels in 250,000 actions. Now, the reason why I say that is the human, to complete every single one of these games, needs about 400 actions to go and do. So even if it made
400, 400, as opposed to orders of magnitude greater for an AI agent.
Exactly. So yes,
Yeah.
like you can think of games completed and levels completed as the numerator, like kind of like what did it do and what was its performance? But the denominator, as we get to efficiency, is going to be number of actions. And so 255 is insane here. I wanted to show you one replay. By the way, we have an amazing engineer on our team. His name's David, and he built all this in the background. But it's so cool that I'm able to just pull up a replay of this winning submission and show you what happened here. And so over here, we have a reasoning log, which is what the developer submits with each action. And it's testing, testing, testing. I'm actually going to speed this up here. Testing, and you can see it's just doing actions that aren't resulting in anything. So it's getting no feedback on here. Can I speed this up? Yeah, one more time. So we're at action. Oh, it just made a change. We're action 200. And it's not until action about 350, I believe. Boom. So now it's like, oh, I'm starting to realize I can actually click something and then something else is going to happen. But
Wow.
still, it's just spamming basically the action space and seeing what can it do for this. So this is not efficient intelligence. Now, it is a proof point and it's a capabilities demonstration about what you can do here, which we love, but this isn't sample efficient intelligence at all.
Is it taking the lessons from the first game and taking it to the second game and saying, okay, now I know I should be moving around in this environment, or is it starting fresh each time?
Yeah. So for each level, yes, it does take what it learned on previous levels forward to the future ones. But I don't believe it does cross game sharing.
Okay. And then when you think about what type of AI is going to saturate the benchmark, solve all of these games, I'm sure you've heard the bitter lesson where generalized AI, kind of end-to-end neural nets, just scaling them up is ultimately going to be the best approach. I think you saw that in ARGI 3, you had a number of submissions that were very focused on specifically solving it. And then you had I think GPT-5 or GPT-4 something. And the general approach did just a lot better. What do you think ultimately is going to be the winning approach? Is it going to be the more kind of end-to-end bitter lesson learned approach, or is it going to be more focused?
My hypothesis for proper AGI, like optimized AGI, after we found it and after we've iterated on it a little bit, is along the lines of the bitter lesson. That's what I think. It's going to be a lot more on those. Now, of course, is it just going to be neural nets scaled up? Well, there's a lot of nuance in that statement in the first place. In some ways, yes. In some ways, no. My goal, or my hope, is that of the thing that beats ARGI 3, there will be, call it 3 or 4 nuggets that are like, holy cow, that was really cool that it was used to solve this thing. Now we need to go take those and we need to go apply it to a more general use case. And so maybe because we don't have language, maybe they're going to go apply it to language models or whatever it may be. But our goal isn't to have the thing that beats this be the exact thing that's going to go become your virtual employee and go like, automate a whole bunch of work. But very tactically, the way I think this is going to go, at least the way I hope it goes, is the solution that beats this, it publishes a paper, and that paper is a really, really cool deal. And then other people go and take aspects of that paper and they go and implement it elsewhere. And then at the end of the day, it's like, holy cow, AGI, the secret to AGI is open, and ArcPrize had a piece in pulling it forward.
Okay.
Very cool. Matt, I think we have a new kind of benchmark that was just released. Let's pull that up.
I can't tell if this is going to be a joke or not.
It might be. I think it's pretty serious. Let's take this seriously. Uh-oh, we're having difficulty finding it.
No problem.
Oh, here we go. Oh. This is bench press benchmark.
Bench.
All jokes aside, this is a lot of weight. Pretty impressive. How did you get to this point? A lot of training.
I tell you what, we had our first kid 15 months ago, and you have to fight for every single second of free time that you possibly can.
Yes, sir.
And if I can get an hour in the gym 3 times a week in the morning, that's all I do. And if you're only doing that, you can only focus on one thing. And so I'm doing just regular bench right now.
Nice.
All right, Greg. Thank you so much for joining us, man. This has been a pleasure, as always, speaking with you. Absolutely love what you're doing. I love that it's open. And thanks for joining us. Thanks for everything you do.
Cool. Awesome. Thanks for having me, Matt and Nick. We'll see you later.
All right, Greg.
Thank you. Bye.
All right. Yeah. So I actually had to ask you, Nick, because I don't do many weights or much weights at all. I had to ask if that was a lot. And you're like, yeah, dude, that's a lot.
It's a lot of weight. Yes.
All right. So we have a few tweets from or a few stories from the feed. I'm going to share my screen and let's go from there. So Alex, if you could pull up, you did it. Thank you. So first thing, I put out this tweet. It was like a throwaway tweet a day and a half ago. And I was just driving and I had parked. I had gotten out and I realized there's so much time that I spend in the car. I usually listen to podcasts or audiobook or some music, but sometimes I want to get stuff done and I can't get anything done in the car while I'm driving. And so I put this tweet out. I would pay $1,000 per month for voice AI that could let me get actual work done when I drive, answer emails, schedule meetings, and do other tasks. And it went viral. So obviously a lot of other people have this sentiment. And so, it really got me thinking. I have the phone. I have an Android right now. I've also used iOS, but they're, maybe a little bit more behind. But how nice would it be if I can just have an assistant that I could say, hey, read me my most important emails. Okay, reply to this one. All right, set up a calendar invite for that. All right, I need to book a reservation here. And I feel like we've been talking about this for so many years. And it feels like it's also very possible. But why don't we have it yet, Nick?
Yeah. Your guess is as good as mine. It's a bit surprising. But like you think about the audio feature on ChatGPT, and in so many ways it's great. I'll use that in the car when I just want to learn about a new topic, and it's very conversational. Maybe the tone can get a little annoying sometimes, but overall useful. And so just taking that a step further into actions, you would think it would be there. But anyway, yeah. So what happened with this tweet?
Yeah, it was a lot of sentiment, a lot of people agreeing. And then Steven Zhang randomly just built it, vibe coded it, put this together. He built his app. I'm going to play this from the beginning. Let me put on the audio. I don't know if you can
This is
hear
a quick
this.
demo
There
of
we
Work
go.
from Car, which lets you answer emails and schedule meetings using voice agents. All you have to do is sign in using your Google account, accept their permissions, and here we go. Hey, can you check my emails for me?
You have one unread email from Broadway SF. It's about a Tipsy Tea event at the Orpheum Theater lobby bar this Saturday. Would you like to read more or take any action on it?
Yeah, can you reply with, thanks, I'll be there.
I've sent your reply. Thanks, I'll be there.
All right, thank you. Can you also check my calendar, please?
You have a dinner with Grace at 7 p.m. at Ken, 252 Divisadero, San Francisco.
Oh, well,
All right, I'm going to pause it there. So you get the gist. Pretty incredible for about a day of work. I think it's hilarious that he blurred his feet. I don't know if you saw that.
Did. I mean, yeah,
Motion blur, pretty good.
yeah, great demo, great view, of course. But yeah, this is just so impressive. This is a sign of the times, right? How quickly these things can come together. Am I going to use this with my personal information? Probably not, but I love that it exists.
Yeah, as a quick demo, it's great.
Yeah.
Like you mentioned voice mode with ChatGPT, and I think that's probably closest, and especially when you use connectors, so you can actually plug it in to you can plug it into your Gmail, you can plug it into Drive, you can plug it into Box, all of these services. I mean, it's only, maybe 8 or 10, but that's enough to at least get started. And it feels like it's almost there, but I don't necessarily think I have the trust to say, go get my emails, reply to this email. Like the interaction layer and the trust isn't quite there for me yet, but it just feels like it's so close, and it just needs a little bit more to actually get the full experience.
Agreed. And I would also say that this is kind of the X and Twitter sphere at its best. I mean, you put out a call to action and someone answers it in 24 hours. It's pretty awesome.
Yeah, absolutely. So I thought this was really cool. He got 1 million views on this. So really cool, Steven. I really appreciate you putting together this demo. And hopefully I get to chat with him soon, which will be really fun. Okay. Next story. Nick, why don't you lead us on this one?
Yeah, so this is our friend Ray, and he is saying goodbye Claude Code, which is a spicy take, obviously. Now, if as you read through this, I think the important takeaway, and look, part of this comes down to personal preference. Some devs want to use the full IDE, others are focused on the command line. But like when I look at this tweet, what I think of is these frontier labs are making such a push into agentic coding. Like they're very competitive already. And so the cursors, replets, cognitions of the world, they need to find their competitive edge. There needs to be something more than, hey, we have Claude inside, right? And so they need to find ways to, increase speed, massive context windows, like better integrations, all of these things to stay competitive. At the end of the day, it's probably a little bit of a personal preference, but this tweet to me is just a sign of how competitive tools like Cursor are able to remain by including these big context windows.
Yeah, and it's interesting because it's very much reflective of platform risk, right? So imagine your Cursor and you're integrating, or you're kind of built on Claude. You're built on a few other models as well, but let's say you're mainly built on Claude, and Claude is also releasing their own CLI, their coding tool, because all of the frontier model labs believe coding is such an important use case. They're going to take it on, right? OpenAI has Codex, Claude has Claude Code, Claude CLI. So it's I don't know. It's a tough position to be in. I'm a former founder myself. I built my previous startup on top of Twilio, who ended up competing with us, and it is not a good feeling. And it feels very akin to what might be happening here. So Cursor, I like Cursor. I like Windsurf, Klein, all of them. But for a lot of them, you are competing with your provider as well, which is a really weird place to be.
Yeah, it's definitely interesting. We're going to see what happens here in this space, though. Yeah, let's go to this next story. So, on its face, this is a small feature, kind of a trivial story, but I think there's something much more important at play. So, if we think about what OpenAI is doing, they're making this huge push into education. I think it was last month or earlier this month, they introduced study mode. So now they have flashcards.
Yep.
And not to mention, ChatGPT is free for college students. So to me, this is just really comes down to adoption, right? They're getting that next wave.
This is a distribution play, you're thinking?
Well, I think it's distribution, but really it's just about creating stickiness. Like they're developing their next set of consumers. And I think as memory and personalization becomes so key to how we interact with AI, the earlier you start interacting with it, the more valuable it becomes and the harder it is to switch away. And so I think that this is a pretty strategic move.
Yeah. Yeah, it does seem like a bit of a throwaway feature, but maybe you're right. Maybe it is more strategic than I'm seeing. I actually did like the study mode where, for those of you who don't remember, basically it's a feature or kind of a custom GPT kind of that rather than giving you the direct answer, it kind of walked you through how to get there. So you're learning along the way, which, great, I guess.
Yeah.
All right, let's go to our next story. Dan Mack posted, GPT-5 LM Arena reign already ended. And as we can see here, Gemini 2.5 Pro, I guess, equaled the score, basically tied for number one, up at 1456 ELO. And remember, LM Arena is based on user votes. It is not a kind of traditional benchmark in that way. It is strictly what is the user preference. And because of that, of course, it can be gamed. When Llama 4 launched, right, they had a specific mode that I can't remember exactly what it was, but they included a lot of emojis, which got people to favorite or prefer their output over its competitor. And so the way LM Arena works is it presents you with two different solutions or two different responses to your prompt, and you're blindly asked to select which one you prefer. So it's not necessarily which one is the most right, but it's which one do you prefer? And that can be based on whatever you think is most important to you. So style, tone, concise, whatever it is, that's what you choose. And it looks like Gemini 2.5 Pro is up there now.
Yeah, not completely surprising that the reign was short-lived. And limitations aside, I think that LM Arena is actually pretty indicative of like a real world test, right? There's certainly some value in it. But yeah, the reigns are short-lived in the world of AI, that's for sure.
Yeah. All right. One last story before we bring on our next guest. There were actually two different quick stories from OpenAI. Mark Chen, friend of the show, he posted GPT-5 Pro starting to develop new mathematics. And this was based on Sebastian Bubeck's post himself, where he basically said, it can prove new interesting mathematics. Proof, I took a convex optimization paper with a clean open problem in it and asked GPT-5 Pro to work on it. I'm not going to read the whole thing, but basically this math is too complex for me to explain, but basically it is solving new math. And I want to get your thoughts on this, Nick, in a second, but I want to show one more post that actually was just published this morning. Boris Power, another OpenAI researcher. At OpenAI, we believe that AI can accelerate science and drug discovery. Here is an example of new work. It was able to design improved variants of the Nobel Prize-winning Yamanaka proteins. So discovering new math, discovering new science. We've been talking about this on the channel for a little while now, and it seems like we're starting to see hints and little seeds of, yeah, it's able to do this, and it's actually pretty darn impressive. So what do you think, Nick?
Yeah, I was looking Sebastian up before the show, and he's a serious heavy hitter. He was a Princeton University professor, Berkeley researcher, spent I think it was over a decade at Microsoft as VP of AI. And so, yes, similar to you, I have no idea what the math is saying, but I'm going to take his word for it. And having the Mark Chen backing him up certainly helps. But yeah, I mean, the interesting part of this to me is all around. At this point, the model isn't just regurgitating something. This is kind of net new knowledge. And as we all know, that's a fundamental component to how people are talking about AGI. And so very, very exciting.
Yeah, especially self-improving AGI, right? I mean, not only I'm personally excited about scientific discovery, healthcare, new drugs, all this stuff that can make us healthier, identify health issues earlier. All of this stuff is really exciting. And then we also have the new math being discovered. Then we can hopefully reapply it to the models themselves. And that's where you get that nice recursive feedback loop and self-improving artificial intelligence. Okay, let's end there. We're going to bring on Charles Packer from Letta. Charles, welcome to the show.
Hey, what's up? Thanks for having me.
Hey, Charles, good to see you again. So, Charles, you are founder of Letta. I first found out about you, and I first kind of got connected with you when you published the paper MemGPT. That was an awesome paper. I want you to just describe it briefly. I made a video about it, but tell us what that was, and then tell us about the transition to founding Letta.
Yeah, I guess MemGPT, I think everyone's like familiar with the memory features in ChatGPT memory, Gemini memory. I think memory is like a feature in probably every single like production chat app. And the way the memory works in practically all those systems is it's tool calling based memory. So there's a language model somewhere in that stack that's deciding, it's looking at like the transcript of the conversation and deciding, hey, like what the user just said is pretty interesting. I should call a tool called like create new memory, or I should call a tool called like edit existing memory. And that kind of concept of like the tool calling memory, that was basically what we introduced in the MemGPT paper back around when GPT-4 came out. So the MemGPT paper actually came out like very shortly after GPT-4 tool calling or like function calling was added to the OpenAI API. And yeah, I think MemGPT also was a big part of like the LM operating system discussion. I know Karpathy had a lot of pretty
really
high-profile tweets that were like, "Hey, let's kind of map out what does it look like to make an LMOS." I think MemGPT's vision of the LMOS was a little bit different. I think it was less focused on like a computer that is itself driven by a language model, but instead like what is the computer you need to build around the language model to actually get like self-improving intelligence. So I think the stuff you're just chatting about on self-improvement, that's exactly like what MemGPT was all about. Like, how do you actually put this incredible model? I think GPT-4 was an incredible model, right? But how do you put it in some sort of system that allows it to self-improve so that you could have a single GPT-4 agent and run it for like a decade, and it would actually meaningfully grow over time, as opposed to, today it eventually derails. You have to compact it, throw it away.
Yeah. So we pulled up the paper, a very fascinating paper. I encourage everybody to go read it if you haven't already, or check out my video where I broke it down. And so how like, first of all, what was the inspiration for like figuring out, hey, we need to really think about memory? And then tell us about that transition to actually starting a company around it.
Yeah, I think the inspiration was, it was really, I mean, so for example, myself, Sarah, and Kevin, we were all like, everyone on the papers at Berkeley, and we were all kind of working on different things. I was working on like RL research, Kevin was working on pure NLP, Sarah was doing more ML systems, but we all got pretty excited when GPT-4 came out. I think for me, I really think the biggest delta, the biggest step jump we've experienced at was 3.5 to 4. So when 4 came out, I kind of like dropped everything I was doing and I started just playing every day. I would just play with 4 all day. And I think the number one thing I wanted when I was playing with GPT-4 was this just, there's no way for this to run for a meaningful amount of time and actually learn over time. But luckily tool calling had just come out in the API. So I was like, okay, well, what if you just like combine tool calling to like have a memory bank attached to the LM, and then maybe, it's a long shot, but maybe that will kind of give it some sort of long running memory. And it turns out that like GPT-4 is just so damn good that it just worked out the box. And I was like, oh my God, wait, it's actually, this is pretty good. And I think from like in terms of going from MGPT to starting a company, I think the idea is that fundamentally everyone at this company at Letta, we're all incredibly excited about self-improving AI, but we're just not there yet. So we're kind of singularly focused on what is the paper beyond or the methods beyond MemGPT that we can actually add to the current frontier models that will actually give you something truly self-improving. I think MemGPT agents, they're great. I think basically what you see in ChatGPT and like Gemini with memory, that's like a MemGPT agent. But I don't think any of us could seriously call like even Claude Code meaningfully self-improving. I think editing like a Claude.md file is like okay, but I think what we really want is like, if you're an engineer at a company, you get provisioned a Claude Code and you use the same Claude Code your entire career, right? And it kind of grows and gets better and better over time. That's something we don't have yet, but I think it's very much it's reasonable to assume we'll get there pretty soon.
And what are the main innovations that you took either from the paper or discovered during the time launching Letta that really set you apart from either kind of just directly using the memory in ChatGPT, if you're kind of just a consumer, or some of your competitors?
Yeah, I think that the number one thing that kind of set MemGPT apart from, I think the reason it was so high impact as a paper is that it's all about like this OS idea where, the language model, it's kind of like a new CPU, like a CPU, it's kind of like bits in, bits out. And the language model is like tokens in, tokens out. So we have this like incredibly powerful CPU, but we don't have like the computer around it. Like, the way your computer works is it's not like you're directly programming bytes that are going into your CPU. There's like a very big tower of abstraction where it goes from like the application layer, then there's like memory swapping happening under the hood. And then at the very, very bottom of it, there's like very tight registers that all this, bytes or like of data that get packed into. I think we have something similar with language models where we have these incredibly good units of compute, but we don't have like the proper abstractions to basically move tokens in and out. And I think like RAG is a very simple example of some sort of LMOS because it's like, hey, let's do like a top K ranking and pull some stuff into the context window. But I think RAG, the problem with that is that it's the algorithm is like written by a human. So a human wrote some cosine similarity search to do top K ranking and wrote that in code. And now that code is kind of like what determines what goes into the context window of the LLM. I think the future, and this is also like why what's different about MemGPT is that the algorithms for like what goes in and out of the context window should really be done by machines themselves, right? We shouldn't have to context engineer. The machine should context engineer itself. And I think that's what you can get if you do all the context engineering through tool calling, right? If you kind of give the LM the ability to manipulate its own context window, and these language models get better and better at tool calling, I think you can eventually build a system where it looks like an OS where there's a ton of like really complex fluidity and like movement happening inside of the context window from like different layers of memory or layers of context, but a lot of it is orchestrated by language models itself.
Yeah, and so I've talked a lot about memory, agent memory, AI memory on my channel, on my Twitter, and like it's so incredibly important as one of the pieces to really see these AI models excel and be able to do real world tasks, and you develop a shorthand with it. It becomes more efficient with memory. Memory is also a very big moat for companies. And I asked the Google CEO about this, so I want to get your thoughts. Given, let's say you're Google and you have all of the information about me already, those all can be memories. And then all of my interactions with Gemini, those can be memories. But if those are stuck within Google's walls and I can't bring them to any other competitor, is it like it just feels like that is going to harm the consumer. And so do you think we are in need of an open standard for memory where memory can be transferred among systems, or maybe there's memory separate from these companies that like Letta can store all the memories, and then like if I go use one of Google's models, it'll go retrieve it from Letta? Like what do you think that architecture is going to look like? Do you think there's a need for an open standard for memory?
Yeah, I don't, maybe I'll comment on the open standard component a little bit later, but I think certainly there needs to be some sort of open version of memory, because I think what's going to happen is that we have these agents and they will become longer and longer running. Like, Claude Code eventually will become something that I was describing where like you kind of only have one Claude Code and you run it all the time, and it kind of has an infinite context window. It's constantly like building up more information and self-improving. And similarly, ChatGPT will eventually, you'll no longer have, message histories on the sidebar. It'll just be unified and it'll be like one system. I think the problem, I think that's okay from a consumer perspective. There's like problems with it, but I think a lot of people will say, hey, that's a trade-off I'm willing to make, my memory getting sucked in. But I think for developers, it's kind of a disaster, right? Because imagine, if you have these infinitely running self-improving agents and you have like an AI at your company doing meaningful work kind of as a programmer, it's really bad if that AI can only function in OpenAI. And there's like no way to ever pull out that, agent if OpenAI goes under. I mean, like one of these frontier labs probably won't be around in a handful of years or like a decade or something. But what if you built your entire like long running self-improving agent on that
Right.
platform? You're like completely screwed, right? So I think what we're trying to build at Letta is like the open version of this, where you can keep all the memories separate from the model providers, and you can kind of like bring this memory around with you. But the memory, it's very hard to just treat that memory as, like a file or block. I think there's like, you have to make a few more abstractions on top to really allow like the self-improving element where the model can improve the memory. But I think in the long run, even for the frontier labs, like a Google and OpenAI, the memory is actually much more valuable than the model, right? Because imagine an agent that's running for like 10 years, a century or something. That agent has gone through many, many different model cycles, right? It's been through GPT-5, GPT-6, GPT-7, 8, 9, 10, or maybe it's been hopped in between GPTs and Claude. But the memory and the state, that's like incredibly sticky. It's been the same thing for like 10 years, 20 years, 30 years. So if you're doing like a Mission Impossible style like break-in operation into OpenAI and you're trying to leave like with a thumb drive the most important things at that company, I think pretty soon the thing you're leaving with is not like model weights. You're leaving with like all the memories that you're like exfiltrating out. So yeah, I think memory being more valuable than the model, that's like coming up pretty soon, as soon as you kind of get the self-improvement to be a little bit better.
Yeah. And so, okay, so Letta is open source. And how do you, like, what types of customers are you getting today? Who are you serving? And what are their use cases?
Yeah, so Letta is open source. The thing that is not open source is we have like a front end that's like a React, like a web app, kind of a playground that lets you like see things. That's not open source, but it's free. And then also we have like a fully open source REST API, so anyone can like vibe code their own version of that. But the core like AI technology, it's all open source, Apache 2.0 licensed, and that's very intentional because we want you to think of Letta as like the way to avoid this devastating kind of like memory locking problem. If you use Letta, you should be able to like, if you want like, be completely disconnected from the internet at some point and like store all your agents in some like, special archive where you put like, all your agents' memories on like Blu-ray drives and lock in like a bank vault or something. So that's like the technology that we're trying to build at Letta. And yeah, sorry, what was the other part of the question? It was like, oh, the customers. Yeah. So
yeah, who are you serving?
Exactly. So I think Letta is pretty special as a company in that we're extremely focused on this very long running domain. So like the agents that are meant to run for a very long time, potentially in perpetuity, and get better and better over time. So I think the largest deployment we have of Letta that you can read about online is with a company called Built. They're actually not using Letta agents for chat purposes. They're basically provisioning Letta agents for all of their customers to like read user data and like look at transactions and basically build these user profiles that are used for recommendations. So that those agents, there's like several million of them now. I think there's like millions of customers that have this, and then like each of the customers has 50 plus agents. It's like dozens of millions of agents. Those agents never turn off. They have an infinite context window, and the way they're set up in Letta, they have a self-editing memory block about the user. So they will learn things like, hey, Charles really likes on Fridays going to this restaurant with his team. Things like that are then used in a separate agent also on Letta to generate recommendations on an app.
In infinite context window, I just want to pause there for a second. That it's infinite because of the work you're doing at Letta. It's infinite because that has access, but like ultimately you're constrained by the context window of the model. So how would it be infinite?
Yeah, definitely nothing's ever truly infinite, right? I think when you're working with like computers, there's no, even on your, you have technically like infinite virtual memory. You can open as many Chrome tabs as you want, but eventually your computer will start dying because of how much swapping it's doing. So with language models, I think there's actually some pretty interesting research that's been happening lately that shows that actually even if you have 1 million tokens, you often are better served in like a sweet spot of like 30K tokens, right? So like with Letta, you can basically set the physical like story or the physical context window to be anything you want but it cannot go over the maximum. So let's say with a Claude Opus, have a 1 million token max. In Letta, you can like set a sliding window to say, hey, I want my context window, for the physical size, like analogous to memory, to be 30K. And then when you send messages to a Letta agent, a lot of the software, this is all the open source software, it basically makes sure that if you ever exceed the context window, it does like a smart compaction. I think the compaction we do is a lot better than Claude Code. It's a lot less destructive because it preserves like a 30%-ish of the context window, and it slides it and does a recursive summary. But the most important thing is that it's not lossy. It's lossy inside the context window, but the agent always has the tools to basically search back into the database, pull out anything it wants. So yeah, it's kind of all the things we're very familiar with, like recursive summarization, truncation, sliding window, things like that. But then with the addition of some very, very powerful tools, so the agent, kind of like in a WhatsApp, in your WhatsApp messages or iMessage, you can always like search the conversation history instead of like having to scroll all the way back. But you can also, tie your thumb out and like pull down all the way until like the very beginning of the message history. So imagine just giving agents tools like that.
Oh, Nick, you might be muted. All right, let me jump in while he's figuring that out. So, are you saying that the context window size of the model doesn't necessarily matter all that much? Because with Claude Sonnet, now we get 1 million tokens. Gemini 2.5, you get 1 million tokens. And there's varying sizes. Does the model context window actually help Letta's performance, improve Letta's performance, or does it actually not matter? Are you looking forward to 10 million token context windows? Does that help? How does that affect what you're doing?
Mm-hmm. Yeah, I think again, using the computer analogy at Letta, we're basically like building, the computer or like the higher level abstraction. So if you're in the business of building computers, when the chips get faster and faster, or like the amount of RAM you can shove on a motherboard like doubles every n years, that's a great thing, right? Because it means that like the ceiling to the applications you can build is much higher. Like every single time, the new MacBooks come out with more RAM, we find a way to like abuse that and like fully saturate like the RAM on our computers. Like we used to think 16 gigabytes.
That's a good analogy,
lot,
actually.
Right? Yeah. So I think with the analogy with like applied to language models is like as soon as we start getting kind of commodity language models that we can run on device that have like 10 million token context windows, I think we kind of unlock a lot of multimodal applications, because multimodal is super token hungry. And right now, I think with like 200K or what you can meaningfully run on like a MacBook or something, like 30K often, that's just not enough tokens to really be like putting image or video data inside. But to answer like the original question, do I think it matters too much? I think increasing context windows matters a lot for multimodal, but I think for agentic tasks where you're kind of trying to do X, Y, Z in some sort of order, like open ticket, closed ticket, triage ticket, assigned to supervisor.
Oh, I think maybe your audio just went out. Oh man, having some audio
Oh, wait,
issues
sorry. I think
today.
I tapped my
There we
mic.
go. You're
Yeah,
back.
okay.
Yeah, sorry. Continue, please.
Yeah. So I think like, obviously I imagine you're probably a heavy Claude Code user or some sort of like tool like that.
Yeah.
So I think in
Yeah.
Claude Code, as soon as like the 1 million token limit came out for the base models, I was internally, as a heavy Claude Code user, I was like, oh my God, thank God, because now I don't have to watch this like incredibly destructive compaction happen as frequently. I can wait for longer. But I think the promise of something like Letta is we're really saying, imagine if the compaction was really fluid and it happened behind the scenes and it also was not destructive, right? Imagine if like this compaction was perfect and it never like had any sort of destructive property. Well, in that case, you might actually end up configuring your Claude Code to have a smaller sliding window, just so that maybe you find that it has better focus, or for cost reasons, so that you're not like blowing up your API bill by always sending like 1 million, or you like increasing to like 1 million size payload and then like reset it.
Yeah. And did you like Dwarkesh put out a blog post a few weeks ago talking about like this essentially we can't reach AGI with the current architecture of models because the models aren't actually applying their learning internally to themselves. Do you agree with that? And like, are you excited about a future in which there's an architecture where the model can actually evolve and learn internally, like like in parallel to also having this external memory?
Yeah, I mean, well, I think that actually with the current models, you can get to the self-improving intelligence through the correct like scaffold or system. I think it's a very hard problem, so it will definitely take, you know, months of like research and engineering work to get there. But I think it's very possible with like the current quality of models. Um, with respect to like memory inside of the weights and outside of the weights, you know, at Letta, we're not like dogmatic about where the memory should go. I think it's all about, hey, these are all knobs you can tune on this bigger LM driven system, and you should tune whatever knobs you can to get the best performance possible. One thing I will say with respect to model weights, though, well, firstly, I think you should definitely, if you have access to the weights, you should probably be updating them. It's kind of a waste to not update them if you have access to them. But obviously, with closed APIs, it's very hard to do that. But assuming you do have access to them, you know, again, this analogy of, you know, in this world where we have self-improving intelligence and you have the agents that run for like a decade, a century, or even longer, and those agents having been through many model cycles, you have to think about like what does the hierarchy of memory look like, and like where do the most important memories go. And I think if you're actually in a world where a single agent will see many different models and will swap those models over its lifetime, then I do think there's a very strong argument that the most important kind of style or like section of memory to like really nail down is the external memory, because you'll end up always having to throw away the model weights, right? I think you do want some sort of mechanism for turning external memory as like a bootstrapping data source to fine tune into your models periodically. But if you're continually like throwing the model away and putting a new model in, then I think it's very hard to make an argument that like the most critical part of this entire system is like the fine tuning, because well, the fine tuning is something you're going to do, and you're going to like kind of throw the system away after.
Yeah. Yeah. And so as you look forward, kind of you're on the bleeding edge of agent memory. What are you most excited about that maybe isn't quite here yet? Maybe you're developing it internally at Letta, or you've seen other research papers start to hint at what's possible with memory. What are you most excited about right now?
Yeah, I think the most exciting thing is, I mean, we touched on this in our research paper on like sleep time compute, but it's the
Oh
idea that
yeah.
like
That was a
when you
great paper, Charles.
yeah,
Maybe
your
maybe
coverage
just
is pretty
explain
good.
what that is more broadly, and then dive into what you're going to say.
Sure. Yeah. I mean, I think for kind of at a high level, you know, I think we're all familiar probably on this call or on this channel with like test time compute, right? The idea that hey, we've discovered that if you let certain models, if they're kind of trained correctly, if you let these models think for longer, basically their IQ improves, right? You let them think for longer, the smarter they get, and like the better the final result. But I think that begs the question, like, if models can think for longer and their output gets better, why do we only ask them to think when we immediately need them to do something, right? Why don't they just kind of like think all the time? Why don't you just have a data center full of GPT-5s just spending all day twiddling their thumbs thinking, right? And they already
Yeah.
know a lot about you, right? So they could do all sorts of crazy things. Like if you had infinite compute, then you could probably have your own chat GPT, have like a multiplex of different chat GPTs that are kind of preparing in advance. They're all saying like, oh, what is Matt going to do today? What is Matt going to do at 1 p.m.? What is Matt going to do at 3 p.m.?
Right.
Let me try to like prepare in advance. And then similarly, once you're done chatting with ChatGPT, you log off. Maybe it should like spend a lot of time thinking about, hey, what are my current memories? Like, how can I like incorporate the information that we just had in the session into like my deeper memory? And maybe I'll do a full rewrite. Maybe I'll just do a little light edit, a little light patch. So the word sleep time compute, it really comes from the word or the phrase test time compute. It's like, hey, you basically have test time when we're asking, hey, agent, hey, LM, do something right now. And then you have sleep time, which is everything else. When the agent or the LM is not even loaded into the inference engine, it's just sitting there in cold storage somewhere. So the sleep time compute paper, it's kind of an academic paper, and it's basically trying to map out like, hey, what is the road to a world where we can have data centers that are always cooking all the time, and agents are just like always learning. They're never not thinking, because I think the premise of test time compute, it's a very strong argument that like, you know, the longer you think, the better things get. So
Yeah.
there should be some mechanism to let AI just think all the time.
Yeah, and it's so interesting because if you also just think about the efficiencies of a GPU, like running it 24 hours a day is actually most efficient,
Mhm.
economically speaking. And then you can apply that directly to sleep time compute. It should be able to do all of these things. And then you get cheaper inference, because I remember from the paper, you don't necessarily need to run that inference and pre-compute, let's call it, at the peak compute times. You can run it when it's kind of low compute, low bandwidth. And then so you get lower latency, right? Because it's doing a lot of the compute before you even start to interact with the model. And then you also get the lower cost. So very interesting. So have you applied that to Letta? And is that one of the things that you're excited about in the future?
Yeah, so it's built into Letta right now. So if you check out the Letta open source, you can play around with an
That's
agent
so
called the
cool.
Sleep Time Compute Agent, which we're basically, it's similar to the MemGPT agent, where it's kind of a chatbot that attempts to learn about you, but it has kind of an agent that runs separately, kind of asynchronously, that does all the memory updates. And these agents all have like a shared memory block. So they're basically editing the same part of a database together. One of them is reading from it and just saying like, so to be very concrete, like in the original MemGPT paper, a very big problem with that design is if I say to the agent, "Hi, I'm Matt Berman," the agent might say, "Oh, this is a great opportunity to write to my memory. I'm going to like do memory insert." But that's a tool call, and now you're just sitting and waiting for this agent. It's going to take twice as long to reply to you because it's doing something else, right? But imagine if, like, when you chatted with ChatGPT or some agent and you said, "Hi, my name is Matt Berman." If it said immediately, kind of like a human would, "Oh, that's cool, nice to meet you, I'm Charles," but then it had kind of like a subconscious that shares this memory as the main agent, but it kind of does a memory update asynchronously. So you can use that today. Also, the recommender system I was talking about earlier that's deployed with Built, that also is using sleep time compute. And I think that the coolest thing about sleep time compute is this concept of learned context, which is that if you do sleep time compute, you inevitably end up in a scenario where you will have a context window and you'll have like a memory block inside of that context window that itself is like the output of like hundreds of cycles of inference. So you kind of have like a section of the memory block where you just have this extremely expensive learned context, like something that took many, many cycles to compute. And I think that's kind of the vision of the future, right? You have these agents that will have context windows assembled from memories, but those memories are so valuable because it's been like, maybe even decades of you interacting with ChatGPT that was required to generate that amazing memory. And I think that's why it's so important that the memory is not locked into OpenAI or locked into like Google. It should be something that you can control and like move around and download.
I could not agree more, Charles. And that's why I'm so excited for what you're doing at Letta. And I just want to say thank you for joining us today and talking about this. If you want to check out Letta, it's letta.com. You can also check out their GitHub project. Go star it, go fork it, go try it out. Charles, thank you so much. Good to see you again.
Yeah, likewise. Thanks, Matt.
All right. Bye. All right. So Nick is still having some technical difficulties. He'll join us when he can, but the show goes on. So I'm going to share my screen and we're going to go through a few news stories before we bring on our last guest, Alan Liu from Skywork AI. Go ahead. Oh, you're already sharing. Thank you, Alex. You're ahead of me on there. Elon Musk, wait until you see Grock 5. I think it has a shot of being true AGI. Haven't felt that about anything before. All right. Now, puffery and hype aside, I just, there's so much to unpack with this single tweet. First of all, he's already talking about Grock 5. That means Grock 4.20 might be coming sooner than we think. But Grock 5 is just a label. I don't know why there's something necessarily different or step function changed about Grock 5. I don't know. Let me know in the comments. What do you think? Do you think we're going to see something incredible, or is this more Elon Musk puffery? And not to take anything away from what he and the entire XAI team are doing, the amount that they were able to accomplish in such a short period of time, getting a frontier model, and not just a frontier model, really like a top 3, top 2 model in the world in just 2 years is simply incredible. But we also know Elon Musk and timelines have not always had the best relationship. So I say keep that in mind as you're thinking about it. This was all based on a post by Prashant, who said Grock 4 beats GPT-5 as top vending bench model with 2 times more sales volume and 31% higher revenue generation. Now, for those of you not familiar, vending bench is a benchmark in which a model is in control of a real world vending machine. and it is tasked with essentially just optimizing the revenue by controlling the inventory, thinking about what to sell, how much to sell, and so on. And so what you can see here is Grock 4 net worth. That is kind of the main indicator of the benchmark, the main metric, $4,600 as compared to GPT-5, $3,500. And very, very interesting. So you can see the total number of units sold and the net worth of the model. And I believe, although I don't know if I have that handy, they actually have a vending machine in the XAI headquarters that is controlled by Grock. So I think that's very interesting, very cool. And then next, we have a new demo video from Figure Robotics. This is from Corey Lynch, director of AI at Figure Robot. Our fully sim-to-real reinforcement learning whole body control is getting quite stable. So you can see, kind of looks awkward, not moving its arms at all, but you can see it's walking through very difficult terrain, gets its foot stuck a little bit, catches itself, and so on. So, but this wasn't the only robot demo that we got this week. Let me see if I could pull it up. Give me a second. So Boston Dynamics also shared a pretty incredible new video, which I'm going to share right here. Let me turn off the audio. So you can see this is their, I forgot the name of this robot, of course, Atlas, that's right. So this is the Atlas robot doing some pretty incredible things, end-to-end reinforcement learning, end-to-end neural network, I should say, being messed with in real time. And it is just very cool. I mean, humanoid robot seems like it's coming sooner rather than later. Yeah, I still want one of these in my house. So last week we got the Figure robot doing laundry pretty successfully. Then we had it walking over difficult terrain this week. Now we have the Boston Dynamics robot being able to dynamically adjust to changing and challenging situations. So there you go. Boston Dynamics coming in with a very cool demo. All right. And then one more story. We have Goodfire AI. New research, post-training often causes weird, unwanted behaviors that are hard to catch before deployment because they only crop up rarely, then are found by bewildered users. How can we find these efficiently? And so they put together a thread, I believe it's based on a paper, basically showing pretty technically how to find these rare issues that might come up as you're post-training a model. And so I encourage you to check this out. And yeah, I'm not going to go through it right now, but just wanted to share this. We'll drop it in the description, drop it in the chat below. And now, Alex, do you know if our guest is ready? And I'll give him a quick intro. Cool. So this is our guest, Alan Liu, who is the director of multimodal at Skywork AI. Alan, welcome to the show.
Hi, how's it going, Matt?
Hey, Alan. Nice to meet you. Thanks for joining us today. I was really excited to chat with you. I reached out to you guys because we saw the Matrix game. And I'm going to give just a quick explanation of what the Matrix game is, and then I have a bunch of questions for you. So for those of you who saw just a couple weeks ago, Genie 3 from Google, it is fully controllable, essentially world simulator. You can kind of think of it as a fully controllable video game that is being generated in real time. It's absolutely incredible. And Skywork put out the open source version of that with Skywork AI building Matrix games. So Alan Liu, thank you for joining us. Maybe tell us a little bit about what Skywork does more generally, and then what was the inspiration for building Matrix game?
Yeah, sure. Yeah, thanks for having me here, Matt. My name is Alan. The full name is Xuchen Song, but you can call me Alan. I'm a AI researcher and tech lead focused on multimodality, generative music, and also spatial intelligence. So currently, I serve as a director of multimodal at Skywork AI and also the CTO of Miraca AI. So yes, like Matt said, some of our key achievements, including the Matrix Game 2, the first open source and real-time interaction world model, and also we published the UniPic called stand for the Unified Picture Model, a unified model for image understanding, generation and editing. Also, we published the Skywork R1B, state of art, the open source multimodal reasoning model. Yeah, so a lot of work from our team, and we believe we are trying to bridge in the gap between the cutting edge research and the real world application. So that's the quick introduce. Yeah, thank you, Matt.
Yeah, of course. And so, like, why do you think we're seeing all of these world models, controllable world models, pop up now? Is there something? Was there a research paper? Was there some kind of insight that you guys had where now it just makes sense? Is it like a compute limitation function that was broken through? Like, why now?
Oh, great question. So from the recent computer vision conference, you can see previously it's mostly about the image generation and the image editing, or even in the last year more about the video things. But for this year, it's more about the 3D and also the word model. I think it's a trend. So like you said, the computing resource is like booming and much more efficiency than before. So that's the one reason. Another one, I think so far the industry publish a lot of great based video generation model. I think it's a great base model for the word model. So based on this kind of great video generation model, and we can add the extra control like the act. So based on this, we can build the word model as a foundation. So I think these two things make that happen, or say accelerate the progress of the word model.
Okay, and do you see? I mean, you named it Matrix Game. Do you see this as the future of video games? Is there do you see this as potentially a way to train embodied AI? Like, what are you most excited about with the future of this kind of technology?
Yeah, good question. So I'm actually not a very good gamer, but yeah, I play some games. In my spare time. So I think it will be one of the formats of the video game, or say gaming. So far, let's say no matter Genie 3 or Metroid Game 2 is maybe a little bit boring to me. Yeah, so it's like you WASD and controllable with your
Right.
mouse. It's just walking or view something is kind of boring. So far, I don't think it's a game, but in the future, maybe in couple years, it maybe can build up a enjoyable and fully interactable, no matter you and users, between users, or between NPC and user. I think that will be more funny when you add more interaction in the world model. But so far, I don't think. So far at this time, it's very beginning time. We just propose a concept of the world model with the interaction with people. Yeah.
Yeah, and so, like, certainly this is the very beginning, but this is the, I say this often, this is the worst it'll ever be. It's only going to get better from here. You probably saw this, but Elon Musk is working on, he's saying, hey, by next year we're going to have AAA games that are completely generated. Obviously taking his timelines with a grain of salt. Do you think, like, because you're on the frontier, you are creating this stuff, so you have a better insight than most people. what would you say is possible by next year? So, and actually maybe start with what are we seeing here? How long are the generations, and how much control is possible? And then what do you think is going to be possible by next year?
Well, lots of questions. So firstly, I would say some simple games or some simple open world game maybe gonna happen in the very short future, like the similar to the Minecraft, or say some open world FPS game like the PUBG kind of something. Maybe gonna happen, but it's not that pretty good or has a core concept like this pretty good game. But so far, I think you maybe can play in the next year. And so far for the diffusion-based world model, it has a lot of limitations. Like you said, it limited by the memory and limited by the real-time things. For our model, we can do for now is like we can memory the hundreds or thousands of frames, which means the couple minutes. I think is a great is a limitation for now, but it's anyway, we will break it up, and also we will make progress on it. So I guess that will be two methods, or say two mechanisms to make that happen. So one is like you may have a long sequence to modeling that. So so far we are the autoregressive diffusion model. So that means based on the past frames, we generate the next frame. So that means if you have a longer sequence, you need the KV caching or say longer KV caching. And the next step, that's also what we currently working on, is the cross-time retrieval. What that means, so it's like when Matt and me join to the same world model, we may start at the different beginning point, but sometimes when we met, we should have the world model consistent. So that means Matt and I may share the very like same view at that time when we have some overlap. And we also call it a field of view. So that means when our field of views shared or say overlap, we should have them retrieve to our model as a condition to generate the next frame. So that's the things to keep the memory longer and also to keep the long sequence happen in the world model.
And it seems extremely compute intensive to run something
Right.
like this. So it's open source. Like what does it take in terms of compute, number of GPUs, size of the GPU? Like what's the minimum specs that somebody would need to run this?
So far for our model, I would say it's kind of amazing. So our model is 1.8 billion parameters for the metric game 2. You can just run it on one H100 GPU.
Wow.
So
that's actually really efficient.
Yeah, right.
Okay.
Yeah, go ahead.
Please go ahead.
But it definitely trade off some FPS or resolution of this model, definitely. So next step, we will build up several tiers kind of models. So it's like we have a most strongest model, has the best resolution, best FPS, but you will cost a lot of GPU for the training and inference. But we will share something like the Matrix Game 2 with the maybe one GPU inference, or say low cost for your deployment kind of things.
Okay. And it's open source. Is it also open weights?
Yes.
Okay. Tell us why you decided to go open source, open weights. And first, thank you for doing so. It's super helpful for other people to know what's going on and to be able to run it yourself. But like, why that decision? Why did you go there?
Not just this model. I think the open source is part of our DNA of the company from the beginning. So when I joined this company around 2 years ago, so by sharing this kind of models, data sets, and toolkits, we actually want to lower the barrier for researchers and help the innovation more faster. And also it's also about the trust. So we actually got a lot of diverse feedbacks about not only this model but also others, and fostering our community around the technology. So yeah, our approach to open source the core research components and build up the product based on this. So that's the way we think is both benefits the research, but also we keep our business model like more faster to iterative. Yeah.
Yeah. Okay. And so as you're thinking forward, I know you just released Matrix Game 2, but as you're thinking forward to Matrix Game 3, what are some of the improvements that you're hearing from the community? What are some of the improvements that you're excited about internally?
Yeah, so that, to be honest, that's a lot. We maybe already working on the Matrix Game 4 kind of thing,
Okay.
something, but I would say it's lots of things need to be focused on and also to be iterative. Just something is more longer, maybe half of the year or 1 year. So I call that Matrix Game 4. But yeah, it's not very definitely, but maybe 5 or 4. So I would say for the most recent version, Matrix Game 4, we will do the larger model with a higher resolution and also the better FPS and the more precise controllable for users. So far, you just WASD and going like it's not a game, right? So we will try to introduce more controllable interaction with users. But for the further future, I would say I would like to introduce the multi-user interactive. So that's we call the game, or say the world model. So the world is not just yourself. You have to interact with the users. You have to interact with the world. So that's the one thing. Another thing I would say, in terms of the multimodality, I would say the speech will be a very important bridge for the when we interact with the world model. So when you play a game, your both hands are occupied by the keyboards and mouse. So most of the time you actually interact with the users by the voice, by your speech. So I would say in the far future or not that far, we should do the speech interaction with the NPC and also between users. We can do the voice interactions. So it's like you say, oh, Matt said, oh, give me a cabin here. Or I would say plant a tree next to Matt's cabin. So that's will
so
be
cool.
interactive world. Yeah.
That is so cool, Alan. And like, okay, so you mentioned two things there. You talked about multiplayer.
Mm-hmm.
I can't, it's hard for me to envision exactly what that even means or what the architecture might look like. Is there going to be a single model instance spun up for multiple people and they're interacting with the same model, or is it duplicated? So like what maybe whatever you can share, like what does that architecture look like when you start to have multiple people interacting with the same generation from a model?
I would say the core model should be same. So it's actually we share the same core model. But like I said before, so it's like when we share the same word model, the model will need to keep the consistent when we kind of have some overlap. It's like when we have a really large word model, we have multi users in that. At the beginning, it's fine. We have a different model to inference or say explore the world model kind of things. But when some people they meet or has some overlap view, in sometimes we should keep that consistent. So I would say it's not a very complex things about the multi-user world model, but yeah, it will have some tough things we have to handle.
Okay, and then the other thing you mentioned, or I've been thinking about, is like to turn this into an actual video game, you need persistence, right? It can't be freshly generated every single time. So, like, how do you think about memory? How do you think about persistence of these worlds that are generated from the core model? Is that something you're thinking about?
Let me think about this question. To be honest, I think fresh generated should be okay maybe in the future. What about your thinking? So I think maybe fine if we have the computing resource efficiency and we maybe have the better model inference in the future. I think the freshly generated for each frame is fine, but definitely we will keep accumulate our historical data for the memory and for the like for the model training. I think it's gonna be a great help.
Yeah,
for
I guess what I'm really asking is, imagine I'm a player and I want to jump in this world, and then you know, I play for 30 minutes and then I want to come back tomorrow, and all the things that happened in the world, the cabin, as you said, the interactions with other players, they all have to persist through the game. But if it's yeah, I mean, if it's freshly generated each time, that still could work, but it still needs to have a history or some kind of memory of everything
Oh
that's
yeah.
happened in the game. So how do you think about that?
Yeah, sorry, I misunderstand it. Yeah, so I think that's what gonna happen. It's not like fully generated about everything. So it's like when you resume, you can keep the historical frames at the memory, and when you like come back again, and you can use the historical frames to generate your new frame, which means like you wake up or you sleep, you resume or you continue to play this model. This should be fine. So that means your historical things will be your word models memory, but it's not about others. It's just yours. Yeah.
Okay, and then like from a company perspective, is Skywork thinking about serving this game as an actual game, or is this just research for future projects you have in mind? How are you positioning Skywork strategically with research like this?
So in terms of this project, I would say our long-term vision is to build a interactive AI system and products. It's not just about game, but also I think it will have some real-world meaningful. It's like when the Fairman training is very dangerous and it's very high cost, but the world model can better to simulate the environment and help you to do the training. I think that's very meaningful. And in terms of the gaming, for example, we already showed the real-time word generation and also the agent interaction. The next step is to turn the player-driven experience and try to make that scalable and cost efficient. So right now we are focused on bridging down the inference cost, making the long sequence generation and more consistent. So yeah, I think all of those are very important. So if we want to play games and support millions of users here, yeah. But like I said, it's in a very early stage, and but we are moving from the research prototype to a interactive for now. Yeah.
Okay, and so you would describe Skywork AI as a gaming company or a
Oh,
research? Like, how would you AI? Like, how would you describe Skywork AI?
yeah, Skyward AI. So Matrix Game is just part of our uh, research project. So we actually have three products in Skyward AI. One just called Skyward AI. We just published that early this year. Is the AI productivity suite. In that is a super agent. You can do the document generation, slides generation, and even the website generation. Is a super agent, and also I serve as a CTO at Murica AI. Is a music generation and editing platform, and also the Skyreels AI focus on the AI video generation and creation. So all of these three products are the business model for our company, and they actually share the same core about this is like to lower the user's creation barrier and try to bridging the cutting edge research to the real world application and help a user to make some cool creation. Yeah.
Awesome. Well, Alan, I really want to say thank you, and I appreciate you joining us and telling us about all of this. I saw it I saw Matrix game. I was absolutely blown away, especially because it's something that technically I can download and run on my own machine offline. It's just really cool. So if you want to check out Alan, if you want to check out Skywork, you could check it out, Skywork AI, and also America AI. And then if you want to check out Matrix game, you can go on Hugging Face. You can get Matrix game 2.0. You can also check it out on GitHub. So Alan, thank you so much for joining today. I really appreciate it.
Yeah, thanks for having me here. Thanks, Matt.
All right. So that was our show. I want to say thank you to our guests, Greg Cameron from ArcPrize, Charles Packer from Letta, Alan Liu from Skywork AI. Also, if you aren't already a subscriber to our newsletter, please do. Forwardfuture.ai is our newsletter. We have awesome news roundups. We have original pieces where we dive deep into different AI topics. And join us each Friday. We'll be here next Friday. Thank you so much. Unfortunately, Nick could not get the tech figured out, but he'll be joining once again next time. So thank you, everybody, for joining